Um, Hello, everyone. My name is Duncan Mifsud. I am a PhD student at the University of Kent. And over here, I'll just be going over my experience as a successful applicant from round one and what went into coming up with the application that I co-wrote with Zuzana Kanachova from INAF Osservatorio di Roma and where we are right now. But before we start, just very quickly, I have to apologize and say if you hear any sort of background noise, that's the hustle and bustle of lab work, because currently I am speaking to you from the lab where we're actually performing the TA right now. So just to give you a bit of an idea of our experience in writing a successful TA application, Susanna and I sort of highlighted four main points in coming up with a proposal. The first of which is we had to identify what problem we wanted to tackle. And that sounds quite trivial, but in reality, there has to be a strong motivation behind tackling a specific problem. After all, your proposal is going to go up against several other proposals that might want to answer similar questions. So you should highlight, what previous work has been done. Is it outdated, or have there been significant challenges to that kind of research, or perhaps there's just a complete gap in our knowledge? So this is the first point in coming up with a reasonable proposal. So the second point is, and I believe several people have mentioned this already, it's very important to identify what is needed to tackle the problem, and this is where contact with a host institution really comes into play. You should have a very good idea of what technical equipment is needed. For instance, my research is in astrochemistry. So, accelerators, ion sources, spectrometers, these kind of things are important to define within a proposal and also within a work plan. What kind of raw materials are going to be used? Do you need pressurized gases or regoliths or different kinds of measuring equipment that can be transported to the site? Perhaps one of the most overlooked areas is how much time and manpower is needed to actually perform the study. Of course, a reasonable time request has to be made. If a proposal is written and requests several weeks worth of data collection, that's probably not reasonable from the perspective of the host institution and also from the funding body. So I believe it was mentioned that most site visits are cater for about a week, and it's been our experience that several of the lab visits cater for 1 or 2 weeks worth of work. But this is all something that should be listed down within a work plan that is sent off as part of the proposal. The third step is then identifying your target Europlanet facility. And once again, this isn't obvious. With 35 laboratories and technical facilities across Europe and several field sites, it's important to define why a specific laboratory is perfect for your needs. There might be a few laboratories that are capable of doing similar or identical things, but it's important to really pin down why laboratory A is better than laboratory B. And perhaps, due to current restrictions in travel and actually going to perform the TA due to the ongoing coronavirus pandemic, this is even more important because laboratories and facilities in certain countries might be subject to certain national restrictions that would make travel and work just that little bit harder. So it's important to really identify why a particular Europlanet facility is advantageous to your study. There is a link just there at the bottom of the screen to all the facilities that are offered as part of the Europlanet project. And finally, step 4, of course, this all has to get written down into a proposal. So it's important to give context for the work, why it's the motivation for it, and summarize previous findings. But it's also important to emphasize why your work is going to be key in answering a research question. Once again, this proposal is likely to go up against several others that are looking to answer similar questions or questions within the field. So it's important to sort of highlight why your research or your proposed study is really key to answering the questions which you've highlighted. And of course, perhaps one of the most important thing is to include a reasonable and detailed work plan for your study. I believe John touched on this just a few moments earlier. So this is a short cartoon summary of all that. So what has been our experience as part of applying during the first round of the TA applications? Well, Suzanne and I applied, we presented a project called a systematic study of sulfur ion radiolysis of simple oxide ices. And what we really wanted to see was, could you form sulfur-bearing molecules from ices which did not contain sulfur as a result of implanting sulfur ions into those ices, and then detect those sulfur-bearing molecules through various spectroscopic and spectrometric techniques. And you can see here on the screen the first part of the TA proposal that we submitted, listing 3 to 5 of the main scientific objectives of the project. Now these are just short bullet points, but they really do get through most of the information, most of the context that surrounds our study. And in particular, the last 2 points really, in my opinion at least, they really highlight why the study was important. Our systematic study would help bridge the gap between previous studies which were non-systematic in nature, which is something that astrochemistry unfortunately suffers from. And so really provides that really key importance as to why these studies should be performed. And the last point highlights the contextual information. So how can we apply our results to real, natural situations? So the interstellar ice grains, the icy Galilean satellites, which is the focus of my PhD, and so on. So to summarize, what did we want to answer? Well, specifically, we wanted to answer, can SO2 and several other molecules, but particularly SO2, form as a result of sulfur ion implantation into these oxide ices? What did we need? Well, we needed an astrochemistry chamber, and that's where we got in touch with the host institution, which is the Atomki Institute for Nuclear Research here in Debrecen in Hungary, where an astrochemistry chamber called ITSA is currently in place and up and running. We needed an ion source to generate our sulfur ions, and we needed the pressurized gases from which to create our oxide ices. Now, we had contact with the Institute before we submitted our proposal, and we ran our ideas past them, and they thought, yeah, this is something that can happen at the facility. So we got the green light from them, and then we wrote up our proposal and presented it to the Europlanet Society for peer review and adjudication. Here you can see some of the facilities here at Atomki at the ICE Chamber for Astrochemistry, which is where I'm sitting right now. It's literally just behind me. And of course, we were successful in our proposal. So just to give you a rough timeline of how that happened, we applied in early to mid-May, and we received a notification of the approval to perform our study in, I believe it was the first week of July. So not a very long waiting time at all. However, obviously, because of the ongoing coronavirus pandemic, we had a slight delay in actually performing our TA, and so it's occurring now in December. And we expect it to run for 2 weeks. We were granted 2 weeks, which is 10 days worth of experiment time there. And you can also see on the screen there the press release, which was released by the Europlanet Society on their website earlier this week. So that's just a brief word from me about successful applications and what to focus on, perhaps. So of course, special thanks to Susanna Kanachova, who wrote the proposal with me, and also to the Tandatron staff here at the Atomki Institute.